This stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hello, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is what I'm calling collaborative distributed architecture for automixing, which is a mouthful. We'll get to that. But first of all, hey, it seems like my camera is back. Awesome. It turns out that the issue was I had to just pull out and plug back in the cam link. So hooray for hardware issues that are solved by unplugging and plugging again. All right, so in case you're new here, we are doing real-time audio processors in REAPER using the JSFX language. We are in the process of making an Automixer. It's an effect that helps you mix automatically multiple microphones that may be open in a room. So think of like an interview, a round table, that kind of setting. Yesterday, we implemented what I call a distributed architecture for automixing. And now we are going to implement some facilities that will get rid of a couple sliders and make everything easier to use. Oh, Bo is here. Hello, Bo. It's great to see you again. And yes, the camera is back. All right, so the implementation that we are going to come up with is inspired by the original Automixer by Corey Scogin. And if you are interested in seeing how he does it, then this source code is great. It is 130 lines of code. And it taught me so much about JSFX and even digital signal processing in general. It really is great. Right, so the crucial parts are this and that. So how about we steal some of this to begin with? Let's have this in a buffer, because that's what we are going to have to refer to. First of all, what is the issue that I'm trying to solve? Well, we now have this architecture where you have the Automixer working by putting it in multiple tracks. So you have all your 3 tracks, perhaps more, with all your microphones that are open in a room, and you drop the Automixer into all of them. And the Automixer instances are going to communicate between themselves to determine the attenuation that should be applied to each microphone. By the way, another name for Automixer is a gain sharing algorithm, and perhaps that's more revealing of how it works. It takes the amount of gain that you can allocate to a microphone and shares it between microphones. And that's why I keep saying that an Automixer is like having one microphone in the room and then passing it around, except that you actually have multiple microphones in the room, but it is as if there was only one microphone and it's being passed around. And that's because you're allocating different gains to different microphones. You're sharing the gain in such a way that everything adds up to one microphone. Hello, Tail. Thanks for joining us. How are you doing? So the way that I implemented this yesterday, this distributed approach where there are multiple instances of the plugin and they need to collaborate, they need to collaborate to compute the total gain of all the microphones in order to be able to know how to allocate the gain for each microphone. But right now I implemented this in a kind of annoying way where you have to say how many tracks there are, and then you have to come into each instance and you have to say what is the number of that instance. And for whatever reason, this is not syncing anymore. This is syncing, but this is not. So we have to, I guess, start by fixing that. And this will be the place where we need to fix this. I kind of remember renaming this. Yeah, I remember renaming this and I probably missed a couple places where I should have renamed it. So let's give this another try, because this tracks number is supposed to be the same on every instance. And when we have this fixed, we will work on getting rid of it. So let's have, again, 3 instances. I opened 2 of them, and when I change a number in one of them, the other changes as well. So this is like, how many tracks do we have? And this is like, what is my current track? Who am I in this collective of tracks? Who am I? I am track 1. Oh, I am track 2. But the other settings are linked like that. And the strategy we can use to get rid of this complexity is similar to the strategy that we use to sync parameters. It relies on using the global namespace. And this is implemented in a way here that I will try to implement somewhat differently, but let's quickly look at how it's implemented in the original Automixer by Corey Scogin. He uses the global memory position 0 as a counter of how many instances you have, similar to our tracks slider. The rest of the global memory is used in the same way that we use the global memory. It is to store the RMS of the different tracks. And crucially, when a plugin loads, each instance of the Automixer is going to load, and it's going to run this code that will add 1 to the counter of instances. And that will be the identifier for this plugin. And there is a question here, is there a better way to determine how many instances are running? I don't know, really. This is the best I can think of. And then there is this ID that is just the number that was allocated to this plugin. So this is local to each plugin, while this is a global counter. And then there is this management here that happens when you add a new instance of the plugin, or you remove an instance of the plugin, or you bypass an instance of the plugin. You have to hit stop and play, or you just have to hit play so that this code runs and it reinitializes this counter and effectively reinitializes the global namespace. And there is a known bug here. Perhaps there is a better way to determine how many instances are running, and perhaps there is a better way to avoid having to start playback so that the instances can register. We'll try to think of something and we may explore options, but for now, let's try to implement this. So we will be replacing this slider. We won't ask the user how many instances of the plugin there are. We will count ourselves. And this track current, which is what this is calling the this ID, is also something that we can figure out during this registration process. It is a bit hot in every region here in Europe, it seems like. But I must confess that I like it. Prefer it this way. All right. I think that before we have to dive into all of this complexity, how about we just do everything in the init block? In the original implementation of the Automixer, they have this flag that disables running the init block on every time you hit play. And I don't know why they are doing this. Probably it's necessary for the rest of the magic to work. But for now, we don't have that in our Automixer, which means that we don't have to deal with all this complexity. We can just deal with this much and we can worry about this later. Also, I don't think I need to use gmem like this, position 0 and whatnot, because I can use the _global namespace, which gives me effectively the same result. It's equivalent, it's just a nicer way of thinking about it, I think. So let's replace track current and let's replace tracks slider. And the cool thing about this is that now we could have more than 128 tracks if we wanted, because we would have to have a limit. If this needed to be a slider no matter what, we would need some sort of limit. But because we are doing the registering ourselves, we don't need to have a limit. You can have as many tracks as you want. Great. So I guess the track current is a global variable, but the tracks slider is something that is global. Just like that. To begin with, it will be 0. And then I can add 1. Oh, hang on. I think I just realized why they have this and why they have that and why they have this complexity to begin with. Because you can see that they don't initialize stuff on the init block. They declare the functions, but they don't initialize the instances. They don't register the instance of the init block. And I think I realize why. How do I zero this to begin with? I cannot. I cannot say something like this, because then every instance who is trying to register will zero the counter. So I need to have some other strategy to zero things out. And at that point, I have to deal with this complexity. Hey, there you go. Isn't this fun? And reset count is only used in one place. I don't know why it is extracted as a function. Personally, I would not extract these as functions. So let's rewrite this code real quick to make things different, I guess. Not easier, just different. This is how I would write this. And perhaps this is not consequential to the whole dilemma that we are running into. Because if you think about it, this is preventing the init block from running again and again, but if it runs again and again, it is just declaring some constants and functions. So it's no big deal. Okay, so we will have to bite the bullet and do all of this stuff. And we reset the instance on stop, pause, and error. I think that we have constants for these so that we don't need to look at play stage directly. Yeah, we have stopped, playing, pause, recording, and record paused. And if I am right, we update that automatically on the block section. Perfect. So let's deal with this complexity by rewriting it in our terms. And we will slowly morph this code into something that makes sense for us. So reset the instance on stop, pause, and error. Let's see if it matches our enumeration. Stopped is 0. That is less than 1. Less than 0, I think, is error. 2 is paused. And 6 is record paused. So we don't have an error in our enumeration. Well, whatever. I don't think it's the biggest deal, but I will leave a to-do here. I think I remember reading that this is the error stage, but I don't quite remember. Anyway, so we can say if this is stopped, or if this is paused, or if it is record paused. That subsumes that. And then this gmem0 is what I will want to call global tracks. So now I think it subsumes this comment because it is hopefully pretty clear that we are talking about the stopped, paused, and record paused situations. And then, yeah, you can see that Corey prefers a style of commenting things out, and I prefer a style of making things as readable as I can and avoiding comments, because I feel like comments tend to get stale. Yeah, there is a heat wave going on. Okay. But it's okay in Sweden. Good. Next, rebuild. And this is what I'm calling register. So re-register when playing or recording starts. So there is this whole initialized situation that we'll have to look into. But we can do these checks for playing. Or recording. Those are the two ways you can put the playhead in movement. And then, yes, it is registering each instance. It's saying that the thing is initialized. We don't need this. So remember yesterday I said that you can assign things to global variables to see them. So that's for debug on the right hand side. And I think that global variables already benefit from this. And then this is, oh, this is kind of interesting actually. There is a race condition, I think, and perhaps no one ever ran into this, but I think that in theory you could run into a race condition where you add to the global counter and then you read from the global counter. But these two processes are not, these two lines are not guaranteed to run without interruption. It could be the case that another instance of the Automixer is running at the same time and both instances run this line, then both instances run this line. And in that case, both instances will see the second ID. So we don't want to do this in two parts like this. We want to do this like that, where we add one and we immediately assign that result to another variable. I believe that this is atomic because we are not rereading this. We are just writing to it and holding that value in the stack and then assigning it here. So I think that this is atomic and I think that this is not. So I think that this will not have that kind of race condition. I'm not a specialist. I haven't really measured. I haven't really tested, but this is my intuition. So we ended up with code that is similar, but not quite the same. And I don't like the name thisID. I prefer the name, what is it called? Track current. It's not great, but it is the name I'm using. Now let's think about this isInitialized situation here. The point of this is that this whole thing is going to run on the block section. So it will be running over and over, and we need to detect the transitions. That's what this is about. We are detecting the transition of you were playing and now you're stopped. And this is detecting the transition of you were stopped and now you're playing. That's the point of this isInitialized variable. It is to detect not the state, but the event of starting playback. This is something that came up when we were doing graphical user interfaces, specifically when we are dealing with mouse interactivity. We wanted to have a hold of the current state of the mouse. If you had a button pressed down, we wanted to know that. But we also, and that's something that we can just get for free in JSFX, just by looking at the mouse cap. I think it's mouse capture. But what is not available in JSFX for free, and it's something that we implemented as part of the library, is this notion of detecting the transitions between states. And we sort of want to have a similar story here for the play stage. And the number of possible states and the number of possible transitions between states is much larger in this case. We already have more states than there are buttons on the mouse, or at least in reasonable mice. And I think it's reasonable to go from any state to almost any other state. I don't think you can go from paused to record paused, for instance. Maybe you can, I don't know. But I think you can go from playing to recording, from recording to playing, from either one to stopped, probably from stopped to paused, I don't know. So the number of transitions here is relatively big. So perhaps the best abstraction we can provide is not something like left click. That was an abstraction, right? We had a state of, is the mouse button down or not? That was the only thing we had. Is it down or is it not down? And we introduced the notion of click. I don't know if it was called click, but it was the notion of not down, moving into the state of down. That was a click. But here it would be just too much. We would have play, stop, playing from recording, play from stop, play from paused, stop from playing, stop from record. Well, I guess that's its own stage. But anyway, it would be a lot of states. So perhaps the best abstraction we can provide is just store the previous play state, and then the user can do whatever they need. And with that, I would be doing something that is equivalent, but I think it's more principled than this is initialized situation. Or perhaps I guess I would just call this playing. So in either case, this is playing, right? Whether it's actually playing or recording and playing. Also, I could have this yeah, I think that that is right. I think that this order is right. I store the previous one and then I update. It seems backwards to me because we always update the previous stuff after. But it seems okay. I think that this is what we want. Anyway, so with that, we can have a more principled approach to this whole thing where we don't have the checks for is initialized, but instead we do something like this. If you were playing and you are no longer playing, we need to reset. And the opposite, if you are playing and you were not playing, and I guess it's better if it reads like this, because initially you are not playing. When you load the plugin into the track, well, you may be playing actually. You may load a plugin while the playhead is moving. But in that case, this would be 0 to begin with. The first time you load the plugin, it's 0. So this would be false, which is the correct thing. Right, yeah. So to begin with, this is false. That's so cute. This would be true immediately if you were loading the plugin into a session that has the playhead running. And then this would be false, so that would be true, and this would be true, and then you register the track. And now this is a single line, so I can get rid of the parentheses, and then check this out. We turned that whole thing into a single line, or I guess 2 lines. That's very cute. I think that this is much more intuitive. I hope it works too. Yeah, JSFX also has some atomic operations to prevent race conditions, like atomic add. I forget if it works with the global memory. But I know of it. I read the docs about it at some point, but I don't remember how it works. And I have never used it, so I don't know if it's any good. The documentation, if I remember correctly, seems to say like those are normally unnecessary, and so I think that we probably shouldn't be using this too much. Unless really, really we need it, but I guess in this case we can get away with this. And then this destination value, I think it can be anything, actually. It seems like it can be anything. Yeah, it seems like what this is doing is dealing with error conditions that could, or race conditions that could occur in this part of the problem, let alone this part, but it could be the case that this part of the problem is leads to a race condition, because if there are multiple instances of the plugin running concurrently, oops, I bumped into the microphone. Well, if there are multiple instances of the plugin running, they have to plus equals 1, but we all know that plus equals 1 is just shorthand for this. So it means you have to read this value and write to it. And it could be the case that the two plugin instances read this value, two plugin instances do +1, and two plugin instances write this value. And that's a race condition right there. So perhaps we should be using the atomic thing because we are doing something that may lead to a race condition. I will look into this. I'm really interested in knowing, Tail, have you run into this? Have you used atomic add? And do you think it would be appropriate for this situation? We are really getting into the weeds here. This is very complex, and it's just 1 or 2 lines of code, but it is conceptually, at least for me, complex. It is challenging. Right, okay, so we have the right snippets. I think that this is it's not consequential because we are not doing any work on the init block anyway. So let's migrate these snippets into the plugin in the right locations. And that will not be the right location. We don't want to do stuff on the init block. You want to do stuff right here. And this track slider is something that we removed from the sliders, so we need to also remove from everywhere else in the code. Let's start by doing that. So that's no longer necessary. That was there to sync parameters across plugin instances. Same story here. And this will actually have to show up after that. We'll get to it in a moment. Well, actually, we are renaming this variable, so I'll get to it right now. Now this is the only instance of this variable, so it seems to be in good shape. And I don't need to add 1 anymore, because I'm no longer using the drop-down menu. That was what this +1 was for. When we had a slider, we had the drop-down menu and we needed to add 1, but we no longer need that. So we can get rid of it. And then we can just look for tracks, and it only shows up here. So we can replace that with this, and we are good. Let's find track current. Well, that doesn't change. That's the same. It's a local variable. And crucially, we don't want this local variable to be a slider, because a slider will have its state stored in the project. We don't want that. We want the state to, we don't want this to be part of the state. We want the plugin when it loads into the session, suppose that you save a project, close Reaper, reopen Reaper, we want the plugin instances to re-register, and they may have different IDs, and that's fine. They may have different track currents, and that's actually what we want. Because suppose that someone saves a Reaper project, opens the Reaper project in a text editor, deletes part of your stored state, and reloads the plugin. Right? That's something that could happen. And then the track sliders would be wrong. I don't know, it's a crazy scenario, but that's what I thought of. So what do we need to do? Well, this much perhaps could be part of the library. I don't know, I think that this is too opinionated to be part of the library because I'm looking at the playing stage and the recording stage. And perhaps I should rename this, because it's not really just playing, it's also recording, and it is something like needs to register. Not quite. I guess I'll just drop this in the block section for now and test. In which JSFX section is this code running? I think it should be running on the block section. We don't want this to run on the init section, because then there would be no way for me to detect that I need to reset. Right? Because all the plugin instances, suppose that we are doing this on the init section. When you hit play, all the init sections run, because we currently don't have this. So all the init sections run, but who is responsible for zeroing things out? And that's crucial, because if you stop and play and stop and play, the init section is going to run over and over. So someone has to be responsible for zeroing this. Who will be responsible for that? There is no way for the different instances to coordinate and say you are going to be responsible for that. And there is no strategy we could follow. For instance, say we could give this responsibility to instance number 1. So if your track current is 0, then you could be the guy who zeros this. But first of all, how do you guarantee that track current 0 will be the first to run? There is no guarantee. And also, what happens if you have deleted track 0? Who will be responsible then? So there is no way for the different instances to collaborate like that. So I have to do this on the block section, where I can detect that some other stage happened that puts me into the should reset situation. Oh, and I just noticed something. This will actually be giving me numbers starting at 0, starting at 1. I will be just wasting one slot, but I think I would prefer to have this starting at 0. So I guess I will, for now, just take the race condition and not worry about it. And this can lead to a race condition if both or multiple instances run this line first and then get to this line all together. Okay, yeah, so to answer your question, I think it needs to be running on this section. It could be running on the sample section, but it doesn't have to. It doesn't have to run that often. Anyway, no, I haven't actually run into this, but I would probably prefer using atomic add because it communicates nicely that there might be a race condition. In my humble opinion, your mileage may vary. You could do track current. Yeah, I could. I know. But we already established that you could have a race condition because of the addition itself. This +1 is hiding a race condition. So I think I am with you, and I will probably use atomic add, and I will become a discriminating JSFX user according to the docs. So I think I will have to do this, but first I would love if I could reproduce the error, if I could make this race condition happen. That would be great. And yeah, but this crossed my mind. It's a bit of a hack though. Okay, let's see, we changed 2 files. This is just a comment, and this changed a whole lot. We removed sliders, and we wrote magic code that will do the work of these sliders for us. It looks great. Does it work? I don't know. Let's review this and then give it a try. And I ordered this like this because this is gonna happen first. First, you were not playing and now you are playing. So the plugin registers itself. Ooh, I just realized something. And then you are stopping. You were playing, you are no longer playing, so you reset. And I like this reads in chronological order. Yeah, all of this looks okay to me. We'll see. And what I said is that I just realized is something that happened it happened yesterday when I was showing the original Automixer. I did not hit play, I don't think. So I think that that's why it was not auto-mixing the tracks, it was just muting the tracks. We'll give that a try, but let me first see what Tails said. By the way, if you temporarily move the code to sample, you might increase the chances of the race condition actually happening. Yeah, I will not deal with the race conditions unless I run into it right now. I will not deal with it because I am more interested in knowing if this scheme is going to work in the first place. I mean, it's supposed to, but this is novel. We made this, so it may break stuff. We'll see. But before we do that, let's have the original Automixer by Corey on both of these tracks. And when I turn on my microphone, you can see that there is no signal coming here to master. If I bypass this, then there is some signal going there. And I will have, as I did yesterday, a tone generator there. And I will again decrease the volume of the tone generator. So you can see that with the Automixer bypassed, everything is going to master. But with the Automixer enabled, it's not going to master anymore. And that was odd. And I didn't know what to do about this yesterday, but I think that if I hit play, then, oh, when I hit play, it starts, and then it works. But when I hit stop, it resets. That's annoying. It works if you are in post-production, I think. If you are in post-production, you are editing a podcast, then you are hitting play and pause, or play and stop, and the Automixer will be engaged just fine. You can see that when I start speaking, the sine wave is bouncing down to make space for my voice. It's kind of ducking. But one of the advantages of my implementation of the Automixer is that it could be used live, and I guess you could hit play and let the playhead go and don't worry about it. Your plugin will be running just fine. But it is annoying. It is indeed annoying. But hooray, it worked. What I proposed to implement was implemented correctly first try, which is not usual. Doesn't happen every time. So first of all, I want to deal with... Oh, hang on. I'm not testing my Automixer. I just tested the the issue that I had yesterday. Yeah, so the original implementation of the Automixer is working. Is my implementation doing the same thing? No, it's not. It's exploding. That's what it's doing. It auto-muted the master. It's exploding in every channel I put it. So my implementation is not correct. That's a bummer. But also, I think I would prefer to not have to hit play before I see the Automixer working. So I could just check for this condition as well. Well, that's not gonna work, is it? Because the first plugin will register itself, but the others won't. Concurrent programming it's complicated. It's annoying. You have to think of all the different ways the universe can branch. Well, is this going to be something that we can do something about, or is it going to be the nail in the coffin of this whole distributed approach and we need to revert to the sender-receiver approach? At least in the sender-receiver approach, if some instance is not sending, then we don't worry about it. The sending could be out of sync, and synchronizing all of this is super difficult, if not impossible, to do perfectly. But at least you don't run into these issues. I don't know. It will be fun to investigate all this. Well, let's first try to make our implementation work. I think we saw a similar error yesterday where we were producing about this number, and the reason was we were not taking all instances in account. Let's investigate the numbers we are getting, and I think that it's going to show us here the global variables. Will it? It does. So the number of tracks is not working. Well, it may be working. I didn't hit play. Oh, that's what it is, isn't it? Okay, let's reset everything and drop our plugin on the track. As you load it, and you did not hit play, then the number of tracks is 0, 0. So this loop runs 0 times. The sum of all RMSs is 0, and we get this. Division by a very small number will make up for a very big number. That's what I'm trying to say, a very big number. So I don't want to do the plus infinitesimal kind of thing here. What I want to do is the sum of all RMSs equals to 0? If so, attenuation is 1, otherwise compute their attenuation like that. In other words, an attenuation of 1 is no attenuation at all. So if the sum of all RMSs is 0, don't attenuate. So when you load the plugin, it is in bypass mode, effectively. See, it's just passing the audio through. Then I load the plugin on another track, and it is just passing the audio through. And then I hit play, and it starts bouncing up and down, like it should. And if I change the window length, it will bounce up and down faster. And if I increase the window length, it will bounce up and down more smoothly. Okay, I think I implemented what I proposed to implement, and the mistake was down here, not up there. It was really good to implement the Automixer, sidestepping all these issues by relying on the REAPER routing mechanism. I really wish I could do that in every DAW, so I wouldn't have to think about all these concurrency situations, because REAPER and every DAW aligns, syncs all the tracks before sending them to a parent. And by relying on that, I sidestep so many issues. Yikes. Well, the plugin is doing auto-mixing and it's not producing loud noises, so that's a win. But it only works when you have a playhead running. I'll have to think more about this, because it seems like the crux of the issue is that you have to reset this, because you will need to register again and again and again, so you need to reset this. But there is no reliable way of resetting except for when you're stopping, which means the plugin will not work when you're stopped. But hey, at least this line is doing something better than the original Automixer in that it is not producing silence. That's a win in my book. You could set your infinitesimal so that 1 over infinitesimal is plus 666 dB. I will do that. I think that's a great idea. That's 1 over infinity. So what is it called? It is linear. No, I actually want dB. What is that I want? dB to linear. That's what I want. dB to linear of minus 666. Well, it is a small number. That much I knew, but it is just literally 0. Can I have something like that? Right now is infinitesimal represented as a bunch of zeros. Perhaps it's just that REAPER cannot show. Yeah, it's just that REAPER cannot show this number over here. It is too small of a number, but it exists. So I guess what I need to do is take infinity to be. I think that that will work, right? Because then I will take infinitesimal as 1 divided by that, and then when I divide by infinitesimal, I'll get back to this number. Of course, this function call will not work because I'm calling a function that appears below me. I'll just drop this here for now, and that should work. So now 1 divided by infinitesimal it didn't work. Perhaps because that number is too small and there is no precision in the floating point number to represent that. Yeah, infinity is 0. Oh, hang on. This should not be a negative number. It should be a positive number. But still, I think it will not work. This should be a large number. And it is. Okay, that worked. So again, 1 over infinitesimal. That's a large number, yay. And if I produce that as my sample, then I get plus 666 dB. Hooray, there you go. Kind of cute, isn't it? Yeah, I think it's this. Is this the number we got? Doesn't seem like the number we got, no. Doesn't start with a 5. Yeah, we got a different number. Oh, but you were talking about infinitesimal. Yeah, that's a very small number, and it's shown like this. So there, I guess there would be 34 zeros. Nice. Oh, but it doesn't hold. Oh, that's because I commented out, or I removed the code, and now it's running the new code live and starting to get back to normal. Okay. Fun stuff. Infinity is now this large number. Is this a good idea? Is this going to lead into, especially the infinitesimal, is it going to lead into denormalization issues? I think so. It's a nice gimmick. I have fun thinking about it, but I think that this number is too small, especially because you mentioned it is minus 34. Isn't that above the size of the exponent in a regular floating point? Doesn't this lead to denormalization? I think it does. Yeah, I will look into it. I will look into it. Okay. Can be a fun exercise because I know in theory what the limits of denormalization are, where numbers start to get denormalized. But in practice, I don't know much about it. Haven't really played with it experimentally, so feels like I did one thing and I got myself 35 new things to do. So great, I will be streaming forever. I really have to think hard about this, if there is any way out of this. If you're watching this and you have some idea, please let me know, because I would love my plugin to just work when you drop it on the track and then to remember to reset itself if you hit play so that we can reset if necessary. But well, I guess another possibility would be to have a button to reset. So you would have to drop as many instances as you want and then you would have to click on reset. And then that button would reset the global counter and would notify all instances that they need to rerun. There are ways to get around this, I think. I think we'll do it. I think we'll find a way. It's food for thought. Think about this and come back to me with your idea. But at least we are already in a better position than the original Automixer, I think, because we implemented all the same constraints and everything. But I think that this reads better and this definitely reads better. So I think we are already improving on the state of the art. Let me know if you have a better idea of how to reset and re-register the plugins. Something that works even if you have the playhead stopped. How is your analog tinkering going? It is going very well. I may talk about this tomorrow on the C++ meeting. But as a brief summary, I played around with Room EQ Wizard. Do you know of Room EQ Wizard? It's this great piece of software that is supposed to help you measure the acoustics of your room, but it can also be used for measuring stuff with analog gear. You can measure distortion, you can measure the response in the frequency domain. Without necessarily just feeding it white noise, you can do a sine sweep and it plots everything very nicely. The graphs look great. Lots of fun. And I also, you remember when I had this Arduino powered MIDI controller? I used a foot pedal to send expression messages. And I opened it up and I traced the circuit. You would think that an expression pedal is just one potentiometer, but it's not. It's actually two potentiometers and a resistor. So I learned about all the internals of that. And I guess the best part was the process of opening something up and tracing it, finding the connections with the multimeter and multimeter and whatnot. That was a lot of fun. So I'm still doing that. My room is a whole mess. I have a bunch of components here, so I'm still thinking with things and learning, and I'll share more about this tomorrow. Oh, okay, the normal start below 300, but your original numbers might still be more useful. Well, I don't really see the usefulness of 10 to the 20. I think I saw this in some other plugin or something, but it's not really a useful number. This is as useful, I think. you sent me the schematic for the expression pedal. True, I found some. I don't remember your version, sorry, but I found some online, and they were almost right, but not quite, according to my measurements. Perhaps there are different versions of the pedals to cut on costs or something. Anyway, my version had slightly different values in terms of resistors, and it's not within the same error range as the schematics I found online. But even if they were, I think that the process of measuring stuff by myself was useful, and it was entertaining. So I may talk about this some more tomorrow. For now, thank you, Taylor and Bo, for joining me on the chat. Thank you to everyone else who is watching this either right now, but just not being active on the chat, or later. I know of some people who watch these streams later. Thank you all for your support. Have a great day. I will see you again tomorrow for the C++ Digital Signal Processing JUICE study group meeting. It will be a lot of fun. Yeah. And hey, my camera is working again. Awesome. See you tomorrow. Bye. Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.